Welcome to today's presentation, Level Up with Chef Effortless Infrastructure, your guide to effortless config and audit. Let's go ahead and get started. John, take it away.
All right. Good morning, good afternoon, or good evening, everyone, depending on time zone. As Aaron said, welcome to Level Up with Chef Effortless Infrastructure. As my introduction said, my name is Jon Cowie. I am Principal Customer Architect here at Chef. What I'd like to do first is just break down a little bit of the agenda for this webinar, and then we'll get started into the content. So here's our agenda for today. We're going to start off by defining a little bit what we actually mean when we say effortless in this context. Then we're going to talk a little bit about what you might call a more historical view to applications, a kind of infrastructure-centric. And then we're going to talk about the way that thinking's evolved as practices and technologies have advanced to more application-centric view. We'll then drill a little bit into the effortless patterns themselves and look at some examples of how those are done. And then we'll look at a demo of all of this actually working in a real CI/CD pipeline. And then we'll have some time at the end for questions and answers. As Aaron said, you can submit your questions and answers through the Q&A widget at any time, and we'll be going through those at the end. So let's start with what we actually mean by effortless. It's a word that can have many meanings. So in the context of this conversation, we're going to frame it with a fairly specific definition. And this is what we think of effortless as. So historically, those of you who've been chef practitioners, whether it be InSpec, Chef Infra, Habitat, or any of that stuff, those of you who've been practitioners for a number of years will know that historically, Chef software has been predominantly targeted at deep practitioners, people with a lot of knowledge of their infrastructure stack. And to fully leverage the value of that software has required significant knowledge, expertise, and time to fully realize that value. It's analogous to if you imagine we give you a box of construction bricks and you basically have to assemble them yourself. So what we've realized is that we need a way for customers to realize immediate value from that software. We still want to cater for that deep practitioner use case for people who really want to get under the hood and tweak and change things. But we need a way for customers to realize immediate value from our software without the need to write any code, without the need for that significant learning curve and expertise that you need to drive the full value. And that is effectively what we call effortless. So effortless represents a series of patterns for using Chef's products that will help you drive that value, that doesn't require the knowledge of any code. A colleague of mine likes to say that effortless is our vision of what good looks like. So it's giving you a way to combine all of the products that you've come to us for, that you know and love, giving you a way to combine those products to get that value and to drive your business needs without the learning curve that historically has sometimes been the case. So to frame this a little bit, what I want to talk about is maybe slightly older infrastructure-centric view of applications and infrastructure and the way things are moving to a more application-centric view. So this kind of represents the way that typically infrastructure has been done in a sort of, not specific to Chef even, in any configuration management-driven workflow. So we have a fairly complex stack here. We have the operating system itself. On top of that, we have system libraries. Then you may have software packages on top of that, middleware applications like application servers, IIS, JBoss, Tomcat, that kind of thing. And then you have your application deployments at the very top of the stack. And what you end up with here is a fairly complex web of dependencies from the bottom up, from the OS all the way up to the application level. And in many cases, some of you are doing some or all of this with Chef Infra. That's historically been the way this is done. You have cookbooks that do everything from taking your operating system from the manufacturer's base image to your corporate spec, configuring all your packages, all your dependency stack, your middleware, and in many cases actually deploying your application itself, using Chef to deploy your application code. And the way our products break down, this is particularly for those of you who might be slightly newer to our product suite. The way our product stack breaks down is kind of in three different categories that all move towards this sort of holistic picture of application-centric. So we start off with infrastructure as code, security and compliance as code, and finally application automation as code. And the way our products sit there is that the Chef Infra product, this would be what was historically known as Chef Client. We've called it Chef Infra to more clearly distinguish it from the other things using the word chef. That's your infrastructure as code piece. So that's very much designed for configuration management and that sort of thing. Chef InSpec is our compliance product, so that's security and compliance as code, basically saying, for example, I want my servers to be compliant with the CIS level 2 benchmarks. I need something that actually tells me if that's the case, so that's where Chef InSpec sits. And finally, we have Chef Habitat, which is application automation as code. So what I want to talk about is how that, before I drill into application-centric, I actually want to start with a little poll from everybody, gather a little bit of feedback from the audience, basically on whether you're currently using any, neither, or both of Chef and InSpec. So what I'm going to do is give about 30 seconds for everybody to basically select their options on this, whether you're using Chef, InSpec, both, or neither. When I say Chef, sorry, that's Chef Infra, so that would be Chef Client, Chef Solo, etc. And if everybody could take a second just to submit their answers there, that will kind of help give us a picture of what our audience is and sort of the different areas people are focusing on right now. So I'll give a few seconds for everybody to fill in their answers there. And in the meanwhile, if you have questions and answers at any point during this, please do submit them using the Q&A widget. We'll have plenty of time at the end to drill through these questions. And would absolutely love to hear anything, any questions, anything we can explain further, anything you want to revisit, how this applies to a specific use case, etc. Please don't be shy with questions. All right, so let's have a look at our poll results. All right, so we can see that about 42% of you are using Chef. No, so this is an interesting one actually. It looks like pretty much everyone is using either Chef by itself, Chef and InSpec, or neither. There aren't any of you using InSpec in isolation. So that's an interesting one for us. So what I want to look at a little bit next is we talked about the infrastructure-centric view. So that would be, I suppose, the traditional way of doing configuration management. What I'd like to jump onto is kind of reframing the way we think about these things to a bit more of an application-centric view that we feel also better reflects the strengths and capabilities of our product suite. So this is what I mean by application-centric. We still have the same stack. We still, when we're deploying applications on infrastructure, whether it be containers, VMs, bare metal, whatever, we still need an operating system, the libraries, the packages, the middleware, and the application itself. But in an application-centric view, we actually think a little bit more about framing the way we do these, much more in the sense of individual applications than in the sense of the infrastructure as a whole. So what we look at in this case, and this is going to be the particularly interesting part for using Chef for a while and have been used to doing the entire stack with Chef. We actually look at focusing Chef specifically on the operating system level, possibly a little bit of the system libraries as well. And this is really what you might call traditional configuration management. We're basically going from zero to configuration of the operating system specifically. So we think about this actually, the dividing line with Chef stopping is when you've gone from manufacturer spec operating system. So to take the example we'll be using today, Windows 2016, Microsoft base Windows 2016 image, and the stopping point of Chef is where you've configured that to your corporate specs for Windows 2016. So say the DevSec Windows baseline, CIS level 2, whatever that might be. And what we think about in the Habitat world, now, for those of you who haven't used Habitat, it essentially, we'll look at it in a little bit more detail later, but what it essentially does is gives you a way to encapsulate your applications and codify their dependency stacks and so on, and think about the entire application lifecycle very much in a CI/CD way where everything goes through pipelines as code. What we think about is using Habitat for this entire chunk of the stack. So configuring packages, middleware applications, all of that comes in through Habitat applications. And we have InSpec to verify everything, compliance of both your operating system, compliance of your applications. For example, have I configured Postgres or SQL Server correctly? Does my application meet the compliance specs that we require, et cetera, et cetera? But an interesting thing here that we're gonna drill into a lot with Effortless is that Chef Client and InSpec, or Chef Infra and InSpec, are actually themselves applications that we also manage with Habitat. So what we end up doing here is managing the entire ecosystem of our infrastructure, from OS all the way up to our deployed application, as a series of applications. And that's very much how we think about these effortless patterns. It's treating everything as a series of applications. It's also worth noting, by the way, for those of you who've seen the kind of pricing models for our products, that we have two products. We have Effortless Infrastructure, and we have the Enterprise Automation Stack. Now, the Enterprise Automation Stack is all of our stuff, including Habitat for applications. The Effortless Infrastructure piece doesn't include Habitat for applications, but it does allow you to use Habitat to manage Chef Client and InSpec, or Chef Infra and InSpec. So that's a little distinction I wanted to mention, because that will actually enable you to make use of Habitat to manage Chef Client and Chef Infra and InSpec. Sorry, I'm stuck on the old name for the product. So before we roll on, I wanted to get a little poll as well on Habitat usage from all of you, on whether or not whether you're using Habitat yet, if you aren't using Habitat and you have no plans to, or if you aren't using Habitat and currently have plans to. And that's going to help things as well. And hopefully, if you're not using Habitat, even if you have no plans to use Habitat right now, hopefully some of the stuff I'm going to show you during this will kind of give you a better idea of what Habitat can be used for. It's easy to say, it encapsulates your applications and lets you pin dependencies. What I'm aiming to do today is actually show you some of the value that can drive for your business and give you a sense of where Habitat might actually be useful for you. So we'll give it another sort of 10, 20 seconds just for everybody to chip in their answers there, and then we'll have a look at the results. Again, please don't be shy with Q&A. I can see questions rolling in. Please don't be shy. Ask your questions, anything that's on your mind. We'll have plenty of time at the end to drill into stuff. All right, let's have a look at the results of our poll. Okay, so we actually have an interesting mix here. So there are about 11% of you currently using Habitat, almost half of you not using Habitat yet, but planning to in future, and about the same again, not using Habitat without any plans to. So I'll be interested to see whether what we're going to look at today and the kind of value that shows, whether that maybe changes your mind a little bit on that and makes you consider adding Habitat to the sort of products from Chef that you're using. So what we're going to do a little bit now is look at the actual effortless patterns themselves. As I mentioned, effortless represents patterns for using Chef's products that will help you drive this value. By the way, you'll see a few GitHub links mentioned in here. All of the content from this will be available online. So if you miss the GitHub repos during the webinar, don't worry, we will make those available. They're open source and online. They're not going anywhere. The important thing in a modern sort of workflow using DevOps practices, though, is that the patterns that we're talking about here are defined as code. We're not talking about a wiki page or a README document or sheets of paper or anything like that. But what we're talking about here is actually defining our pattern as code. We'll actually look at some of that code in a second, but I want to just touch briefly on a feature of Habitat that we're using to help us define these patterns, which is something called scaffolding. Scaffolding in Habitat is a way that lets us abstract a pattern for an application. So in this case, we're using it for Effortless. You could use it to say, this is our company version of what a Tomcat app should look like, for example. You can build a Habitat app from that scaffolding, from that defined framework, that lets you basically just drop in the components that change. So in our case, maybe Chef cookbooks or InSpec profiles, or maybe jar files, maybe code deploys, et cetera, et cetera. And this is where you can find these these scaffoldings. We're actually going to drill into this repository in a little bit of detail in a second, so you'll get to see what's in there and what it looks like. This is open source, and this is going to be a living, breathing repository that encapsulates these patterns. So these patterns will change as customer use cases change, as we learn from people's use patterns. We're going to evolve these patterns to always represent what we consider the best practice and the kind of pattern for success with using our product. And as I mentioned, what we're doing in this specific case is defining patterns for both Chef Infra and Chef InSpec to be used with Chef Habitat in the application-centric world. So what I'm going to do now is share my screen quickly, and we'll have a little bit of a browse through this repository together. Just give the screen share a second to start. Okay. So what you're seeing here is the GitHub repository. If you aren't familiar with GitHub, it is effectively all of the source code that comprises these scaffoldings. What you'll find in this repository is we'll start off actually with quite a lot of README documentation that tells you what Effortless is. It gives you some links to the tools it encapsulates. It talks through some stuff for existing users and so on. It gives you a little bit of an idea of what the patterns actually do and some next steps. But what I want to do quickly here is show some of the examples that we have, basically the examples that underpin what I'm going to show you, the patterns for actually using the Effortless patterns. The code for actually using the Effortless patterns. And we're going to look at a specific use case later on that will use these applications. And it's going to be around that area I talked about for Chef of taking a operating system from base spec to your corporate standard. In this case, we're going to be using the DevSec Windows baseline benchmark. So some of the examples we're going to look at here are kind of underpinning that. So we have a couple of examples here. There's all the scaffolding code itself, but in the examples folder, we have a number for both Linux and Windows. And the ones we're specifically interested in this case are Infra. We're doing Windows for the example today, but there's a comparable example for Linux. The one we want to look at today is Infra Windows hardening. So this is using Chef Infra to harden Windows from base spec to a corporate standard, in this case, the DevSec baseline benchmark. So again, we've documented all these repositories that show you how to get started with them, but I'm going to just whiz through some of the code quickly. And what we're doing here is we're basically creating a Habitat application which contains a policy file. Now, we're going to pull how widely used policy files are in the audience in a second. But a policy file is basically the way to think of it. It's all of the good things about roles and environments in Chef without some of the weaknesses, like the fact that they aren't versioned. So a policy file lets you define attributes and run lists, and you then compile it, which locks in your cookbook dependencies and gives you a guaranteed build time lock file, effectively, of all of the stuff that's going to run on your server. So whereas traditional Chef does runtime dependency resolution, so you only resolve your cookbook dependencies when you run it against the Chef server, when you run Chef client against the server. When you're using policy files, all that stuff gets baked in at build time. So I'm going to look at the policy file for our specific use case here. In this case, we have a policy file called base.rb. And this is the entirety of our policy file. We're defining the name of the policy file. We're saying that we're going to get some of our cookbooks from the Chef supermarket, and we're going to get some of the cookbooks from our local Chef repo. We're defining a couple of skeleton attributes. There's nothing actually in those. And then we're defining our run list, which is using a cookbook called hardening default. Now, that cookbook actually lives in this repository, so we're going to have a quick look at that. And in our cookbook, we actually have one recipe, and that basically says we want to include the recipe Windows hardening. Now, this Windows hardening cookbook is available on the Chef supermarket, and this is the cookbook that basically hardens Windows to the DevSec baseline benchmarks. So we're basically using that. We're abstracting that as a cookbook called hardening because we use the same pattern on Linux to basically run a cookbook called hardening. So if you think of this in a cross-platform sense, you could have the same policy file running the same cookbook. So whether it's Linux or Windows, it's the same policy file. And you include branching logic in your recipe that says, if this is running on Linux, use the Linux hardening cookbook. If it's running on Windows, use the Windows hardening. So it lets you genericize a lot of your policy files and stuff like that. What we also have in here is a Habitat plan. Because we're dealing with Windows, Habitat plans are written in PowerShell. If you're using Linux, Habitat plans are written in Bash. And this is the entirety of the habitat that we have here. A lot of this is comments, as you can see, on attributes you can change. But the core of this is we're naming our applications, and we're giving it the origin they're going to end up on Builder, which is kind of supermarket for habitat. The origin would be basically the kind of the namespace. So the package would be called Effortless/Windows Hardening. And you can see down here, we're defining the scaffolding we want to use, which is Chef, and then scaffolding Chef Infra. And again, this scaffolding is available for both Windows and Linux. Further down, we have some optional settings, like you can define a custom CA certificate bundle. If you're using self-signed certificates internally, you can kind of give it a custom certificate package. You can pin to specific Chef client or Chef DK packages, et cetera, et cetera. But the defaults will basically use the latest published version of Chef client. And that is essentially all we need to build an application which will run Chef in what we call solo mode. We'll come on to that later. Run Chef in solo mode and take a Windows 2016 server from 0 to DevSec configured. Now, what we're going to do is jump quickly back to the slides. And I want to quickly pull just to get a little bit of a sense on how many people are using policy files at their company. So again, we have the similar questions, whether you are using policy files, you aren't and have no plans to, or you aren't and you do have plans to. So again, we'll give about 20, 30 seconds just for everybody to record their answers there. I'll talk a little bit as we look at the demo on some of the guarantees that policy files give you that really play well into this application-centric view, especially as it pertains to compliance. But again, please don't be shy with your questions and answers. We have plenty of them rolling in, but we have plenty of time at the end as well. So please chip in with questions. Anything, even if it's something you'd like me to explain again, you're worried you didn't understand, any questions you have, don't be shy. Chances are if you're thinking of a question, unless it's super specific to your business, somebody else in the audience is too. So please don't be shy to ask. All right, let's have a look at our answers. Okay, that's a pretty good spread. We have about a fifth of the audience currently using policy files, about 34% not using policy files, and about 43% not using policy files but planning to. That we see, that does reflect a shift we see as we've kind of centralized on policy files as being what we believe is kind of the best practice for using Chef, especially in this particular workload. And we do see a lot of shift in customers moving towards migrating from older Chef workflows towards policy files. All right, so on with our slides. To kind of revisit what we talked about there and to sort of talk about exactly what you get with the effortless patterns for Chef Infra and Chef InSpec. What we're looking at in general is basically using a build process. So this would be a CI/CD pipeline to pull down all your cookbooks or InSpec profiles and create a single deployable package. So in the case of Chef InSpec, which is the example we looked at, what we have is an application which contains your cookbooks, your policy files, an up-to-date Chef Infra client, and the latest best practices baked into the scaffolding. It's worth mentioning that we'll touch on this again later, but Chef Client in this case is running in solo mode, which means it's not pulling cookbooks from a Chef server, although it does report into Automate for visibility and compliance status. And the reason for that is this application actually contains the cookbooks itself. What we want to do is make sure that when you build your cookbook application on your developer workstation, you know that the artifact that you produce does not change until you build a new version of the application. And that's one of the guarantees you get with policy files too, that Habitat doubles down on. When you compile your policy file on your local machine, it makes sure that the set of cookbook dependencies that you built into your application never changes. So whatever server, if you run that exact application on a cookbook 5 years down the line, it will still get exactly the same versions of everything you built it with. And Habitat extends that approach outside of the Chef Infra specific world to all applications. So when you build your Chef Infra Effortless application using Habitat, that will lock in a specific version of Chef Client to that application build, specific versions of all your cookbooks, so that whenever you run that application version, it will run against that version of Chef Client. So what this means, actually, if you think about cookbook upgrades, rather than you having Chef Infra client running on your servers, managing its own upgrade using the client updater cookbook, for example, you actually manage that update by specifying a new dependency at the build stage on the developer workstation, so that the application that actually runs on the server is managed via Habitat, pulls in the new version of Chef Client as part of that process and runs it. So it really moves a lot of the control of all that stuff to the left, to the developer workstation, if you imagine a left to right pipeline from developer to production. Similarly with the Chef InSpec application, that contains your InSpec profiles. If your InSpec profiles are loaded into A2, what Effortless actually does is it pulls those profiles down from A2 and it bakes them into your Habitat application as well. It gives you the up-to-date Chef InSpec client, and it gives you the latest best practices that come from InSpec. And here are some of the aspects that we just touched on there, just to reiterate them. At runtime, Chef Infra works without Chef Infra servers. So that's Chef Infra server as in the cookbook store. It uses Chef solo mode. So it's using Chef to basically run locally against the cookbooks baked into your Habitat application, and then send its data to A2, which we'll see during the demo portion. Similarly, at runtime, InSpec is not pulling your profiles from Chef Automate. The profiles that are stored in Chef Automate, or those you declare locally or in Git repos or in Artifactory or anything like that, are vendored in at build time and baked into our Effortless application. So again, what you build at build time, what you test against at build time, is what you will get in production. We're using Chef Habitat to manage Chef Infra and Chef InSpec. And what that does is it provides a pool-based update strategy for continuous delivery. So the Habitat supervisor is running on your production nodes, managing your Chef Infra and Chef InSpec applications. And with Habitat's update mechanisms, it lets you control how those updates are propagated out to your production infrastructure. In the case of Chef Client, for example, which has historically not been the most pain-free update strategy, you control the update at build time, and Habitat will pull in the new version of Chef Client and manage that life cycle. It's also worth mentioning, just to jump to a question that flashed up, but that does reflect a point around things like OHI data and so on that you get from Chef Server. All of that data is actually saved to Automate. Like the full node object is saved to Automate, so you get the full visibility layer. Really, what you're not doing is pulling the cookbook data from a Chef server, and you don't have that runtime dependency management piece, where essentially you only find out exactly what cookbook versions you get when you actually run Chef Client. In this case, you find that out when you build the application and they're baked in. But I'll show you an example of the visibility stuff when we look at A2 during the demo portion coming up next. You actually get all of the visibility data that you would have using Chef in the existing way in tandem with Chef Server in A2. So that does actually bring us on to the demo portion. And what we're going to look at is a specific use case that kind of touches on a lot of the things we mentioned here. So our specific use case, in this case, we're going to be using Azure DevOps as our CI/CD environment. Part of the reason for doing that is because it doesn't involve actually building an entire CI/CD infrastructure to do this demo. I can leverage Azure DevOps and basically upload the pipeline there and make use of their build agents. We're going to spin up an A2 server from scratch. We're then going to take a stock Windows 2016 image, and we're going to harden it to the DevSec baseline standards using the applicable cookbook. We're going to verify that we've done that using InSpec. We're going to report the status of our operating system build image into A2, Automate 2. What we're then going to do is use Terraform to spin up a server from our hardened image, so that would be analogous to now provisioning application servers from your sort of golden image operating system image. And we're then going to report the status of that into A2 as well. You can see the GitHub repo here. Again, this is open source. All of the stuff you need to run the demo that I'm going to show you is in that repo. So it gives you the Azure pipeline definition, it gives you the Packer scripts that we're going to use for building the image, all the Terraform. I'll touch on how that plays into Chef licensing and the bits and pieces you need licenses for. as we go through the demo. But this repository is basically there for you to use. It's on GitHub now, and all of the stuff that I'm doing in the demo is in that repository. There's no magic here that you can't get yourself today. So I'm going to jump over to my screen share again, and what you'll see here is basically the actual repository itself. This is the GitHub repo that everything's driven from. The content, basically everything you need to get going here, everything you need to run this pipeline from scratch is documented in the README. It's worth noticing, if you're familiar with Azure DevOps, there are a few extensions you need for this installed into your organization. And I've included documentation on all the configuration around what Azure DevOps configuration you need, all the setup you need, how to give the pipeline its configuration, things like credentials. There's screenshots of what everything should look like, etc., etc. And what we're going to be using as part of this are two pre-baked Habitat applications that you can find on the public Habitat builder. So these are called Audit Baseline, which is the InSpec portion, and Config Baseline, which is the Chef Infra portion. And what these applications do, if I drill into this, they are available for both Linux and Windows. If we look at the Windows one, you can see all the dependencies that this application has at the bottom. But what this effectively does is gives you an application that will harden a Windows, basically Windows 2012, 2016, I think 2019 as well, definitely up to 2016. The config baseline package will harden that to DevSec Windows baseline standards, and the audit baseline package will verify compliance. Now, these applications are public packages on the public Habitat builder. You can use them yourself. Right now, these correspond to the DevSec baseline package. Now, what we do want to do in future, and this is something to look for in future from Chef, is we also want to have these prepackaged Habitat apps for our customers for things like the DevSec baselines. Sorry, not the DevSec baselines, for things like CIS for CIS level 1, level 2 for Windows and Linux, et cetera, as a kind of premium content offering. And that's something you should look for coming up from Chef. Right now, the ones we're publishing here in the open are the DevSec baselines. Those are based on open source cookbooks and InSpec profiles. And those are essentially what we're going to use to drive the demo today. So what I want to show you here, unfortunately, I can't run the pipeline live. As you'll see at the side here, it takes about an hour to run the pipeline through, and that's simply more time than we have for the demo today. But what I will do is actually talk you through the different components of the demo. The Azure pipeline.yaml that you'll see in the Git repo does exactly these steps. I uploaded this profile today. If I jump back to the pipeline definition, you'll see there are two runs. Prepare the documentation. The first one will fail because you authorize it to use the Azure subscription that the pipeline corresponds to. The second run today, which you can see ran 4 hours ago, passed to what that's actually doing. So the first piece is the pipeline is provisioning A2, and that's using an ARM template, which is the Azure Resource Manager template. And that's essentially going to spin up an A2 server from scratch. So you can see we're doing a bunch of stuff here. We're cleaning up our existing resource group because this is a demo environment. It tears down anything that was built beforehand, gives us a couple of warnings just saying if anything's left there, please delete it manually. And then we're deploying an A2 ARM template to basically spin up Automate 2 server. We're then doing some pipeline stuff. Effectively, what we do here, because this is a brand new A2 server, for those of you who haven't used A2 before, when you want to have Chef or InSpec talk to A2, you have to both have the URL for the A2 server and you need to have a token that authenticates you to the A2 server. Because we're spinning up a new server here, what we're doing is we're setting some internal variables to the pipelines that expose that token and URL that we can then consume in following stages of the pipeline so that both our OS build image process and the instances we're spinning up will dynamically be added to that A2 server and be able to talk to it. What we do is there's an output A2 settings part here, which will give you the URL to A2, the username and password to log in, and also the API token that will let you send data to it. Because this is a recorded demo that's going to go on the internet, I'm not going to click and expand that section, I'm sorry. But if you build this pipeline yourself, this output A2 settings part of the pipeline is where you're going to go to look for that information to log into your A2 server. The next stage is we're actually going to build a Windows image. Now, what we're doing here under the hood, and again, all this config is in the Git repository, what we're actually doing here is we're using HashiCorp's Packer to take the base Windows 2016 image that Microsoft produce, and we're then going to run Chef and InSpec. We're going to run Chef to harden it to DevSec baseline. We're going to run InSpec to verify that configuration. And then what we're going to do is we're going to register that as a machine image in Azure. It's going to be available as a stored image, as a managed image, for us to build our infrastructure from. Now, you can see there's a couple of things making sure that Packer can talk to A2. That's filling in those variables that we set in the pipeline. And we're installing Packer on our build agent and setting up the environment variables that Packer needs to know where its tooling lives. Most of the stuff, and you can see the part that takes 27 minutes because Windows builds are a little bit time consuming, is that this is the Packer build. This is where we actually do this build process. And what I want to do is just show you a couple of things here. There's a lot of output in Packer, but what I actually want to do is show you the parts where we're running Chef client and InSpec. So a lot of this stuff is installing Habitat applications. So we install the Windows Service Habitat packages, which is what we need to run Habitat applications on Windows as running services. We're installing all the various dependencies that our applications have. We're installing Habitat Supervisor, which is the thing that actually runs the applications. And you'll see here we're installing the Effortless Config Baseline package. So that's the one that I showed you on Public Builder. So it's installing that. And we're installing the Effortless Audit Baseline package, which is the other one I showed you. That's the InSpec component. Now what we're doing is we're running Chef Client, as you can see here. The version of Chef Client I'm using is slightly old here. It's 14.11. We're on the 15 series now. But you can see that our cookbook is running the patching default and hardening default cookbooks. This is built from a slightly different Git repository than the scaffolding, but the patching cookbook is actually not doing anything here. It is the same hardening cookbook. You can hear we're depending on Windows hardening cookbook, which is the version available on the Chef supermarket. And what we're doing is we're doing, again, completely standard Chef client run being driven by Habitat. So you can see we're converging 31 resources. We're doing all the stuff that we need to harden our server to the DevSec baseline benchmarks. A bunch of things here like password, policies, all the good stuff that secures Windows and configures it properly. And what you'll see at the bottom, if I scroll down a little bit, is you'll see our Chef client run completed successfully. Now that's the config baseline portion. So that's using Chef client to take it from the manufacturer's operating system image to our corporate spec. But what we actually want to do now is verify that that is in fact the case. So what we're now doing is run audit baseline, which is the InSpec component managed by Habitat. And we're running, here you can see the DevSec Windows Security Baseline. And we're doing an InSpec run that basically checks all the compliance requirements of that standard. And you can see they're all green. I know this because I checked earlier. And at the bottom it says basically 71 of our controls were successful, 0 failed, 0 skipped. So that's basically verified during our OS build process that we're compliant with the standard that we've set. Now what this means, if InSpec fails here, our OS build actually fails. So if InSpec fails, if we don't verify compliance, our image will not be saved as a managed image in Azure. So what that means is only an image that is verified compliant with our corporate standards will actually be registered as a new version of the golden image. The rest is effectively now that's successful. You can see that we're basically capturing the image, and that is then registered. That's then registered as an image with Azure. You can see the image name is J Cowie Effortless Windows 2016. I'll show you just quickly the A2 view of that. So what we get in the compliance view of A2 is you can see we have our Packer Win 2016 object, and this is the output. This is the output of that audit baseline run. You can see that we're actually saving to A2 the result of our OS image build, and you can see all the controls passing here and see the root profile, and it shows you that total controls 45, past controls 45. So that lets you see in A2 that your OS build pipeline is compliant. Over and above any images that you've spun up, it actually shows you that the process you're using for building your baseline golden image is compliant as well. And you can actually see in InSpec, right now you can actually see the scan history. In this case, I actually only have one image because this is a brand new pipeline. I've only built the image once. But you can actually see the historical build status of your OS build pipeline and effectively see whether that has failed or, historically failed, whether it's been succeeding, and so on and so on. Back to our pipeline for a second. What we then do now we've built our image, we now have a Windows 2016 image saved as a managed image in Azure that's compliant and verifiably so, and we've seen it in A2. What we're actually going to now do is use Terraform to spin up an instance from that image that we can then use for application workloads. You can see a bunch of stuff here. Again, we're populating the effortless app configuration. What that effectively means, as I mentioned, we have those pipeline variables that are basically setting our A2 URL and token. With Habitat, what we can do is after we've built the application, after we have the artifact, is you can actually pass in config at runtime. So, for example, you could have the same application, when you pass in environmental differences, for example, use this Active Directory server or talk to this DNS server. You can pass those into runtime if you desire, and that's what we're doing here. We're using that stock config baseline package on Public Builder, and we're passing in the configuration we need to report to the A2 instance that we built during this pipeline. We're then running Terraform init to make sure that we basically have all of our plugins installed. We're running Terraform destroy to basically make sure we're pulling down all the previous instances that we build from other pipeline runs. And we're then doing Terraform plan and Terraform apply to spin up an instance of Windows 2016 from our saved image. So if I drill into this a little bit, you can see the Terraform output here. So we're pulling in the saved image from the Azure Managed Image Store, which in this case is that Jon Cowie Effortless Windows 2016 image. We're doing all the work to spin up virtual networking security groups, etc. And you're spinning up an SVM. We're doing a couple of things at the end to basically then, once we've spun that up, what we actually want to have our new image doing, bear in mind we still have the config baseline and audit baseline applications installed because we installed them during the golden image process. What we actually want to do now is have those running permanently because we now spun up a server that's going to be potentially long running. We want to continually verify compliance and configuration management. Sorry, excuse me while I take a sip of water quickly. And what we want to do now is make sure that those applications continue to run so that while the instance is running, we're always verifying that that is compliant and verifiably so with InSpec. And you can see at the end, our instance built gives you a bunch of information on its IP address and its public IP address and so on. These will be torn down after the demo, so it's not particularly secret. But what we can do now, if we jump into A2, as we can see, if we go to our infrastructure view, we can actually see our Effortless node running Chef. Now, it's set to run Chef every 30 minutes. So by the time I finish talking you through this, you should actually see that it's run Chef again. This instance has been up for 3 hours. I ran the pipeline to configure this demo environment a little bit earlier today. You can see that it's running Windows. And if we drill into that, you'll see something very, very similar to what you'd see if you're running Automate with a Chef server. You can see that our node has 100% run progress. Total results 31 successful. And you can see there all of the things that have happened to make that happen. You can see they're running from the Windows hardening cookbook, et cetera, et cetera. You can see all that's done. You can look at the run list for the node and see that we're using hardening default. You can also look at the attributes. So to the OHI question we had earlier, this again is the full OHI information that you want to, that you expect to see from Chef already. This is still saved back from A2, so you still get all the information. For example, we can drill into the cloud section and see that it's running on Azure. You have all the information on CPUs, memory, etc. that OHI gives you now. What we can get also is our run history. In this case, because Chef's running every 30 minutes, You can see there have been a bunch of Chef runs since about 2 p.m. I'm based in the UK, so these timestamps are in GMT +1. So you can see that we've had a bunch of Chef runs, all of which have been successful. And actually, I suspect what we'll see if we go back to infrastructure is now that Chef client ran a few seconds ago because it's running on a 30-minute loop. What we also see if we go back to the compliance view is, you notice I skipped over earlier when I showed you the Packer image, but we actually have two nodes saved in here. We have the Packer image, the Packer Win 2016, but we also have, again, this Effortless node, and that is the same node that we built. This is our Azure node that you can basically, we've spun it up running our image, and you can see they're both running Windows Server 2016. They're both running the same version of the operating system. And we can drill into that server and actually see, again, that we have 45 controls, past 45 controls, etc. We can see our scan history. So again, InSpec on this one is running every 30 minutes. So unlike the Packer instance where it ran once, just at the build time, in this case, we're running every 30 minutes. So you can see our historical build status ever since the image was built, again, 14:30 UK time. You can see that we have 6 runs, all of them succeeded. So what that's giving us is, and you can see there's some graphics here, you can see our total nodes. You can see when I built it, we got immediately 2 passing nodes. You can see compliance scan failures down here. We haven't had any today because they've passed, so there's nothing in there. You can see what profiles we're using, in this case, the Effortless Audit baseline. And what this is actually showing us, oh yes, and you can see passing and failing controls by profile. What this is showing us, though, is that all stages of our pipeline are actually compliant. So our OS build image process is producing a compliant image, and then we're actually pulling in that hardened compliant image to build a Windows 2016 server from that compliant golden image, and then we can use that to deploy application workloads. And this kind of shows you how A2 becomes your visibility lens in this. So at all stages of this process, from build to running production servers, all of this reports into A2 and gives you that centralized view of running on our servers and also the compliance status at all stages through this pipeline. So I'm just going to jump back from the demo window to the slides. So that kind of talks you through this demo workflow that we have here and shows you all of the stuff that I mentioned we were going to do, actually. So we have here our Azure DevOps pipeline, which I showed you, which again, you can find that in the repository. It's ready to rock. Literally everything I did there, the pipeline that you see in Azure DevOps, if you configure it with the variables mentioned in the README and you upload that Azure pipelines.yaml, it will give you exactly what you saw there. It'll spin up A2. Now, you may have noticed at the top of my A2 window, it actually says I'm using a Chef Automate trial license, which expires in 59 days. When you spin up A2 using this with the default settings, it will spin you up a demo server with a 60-day trial license, after which it expires and you need to get a license from Chef or apply an existing license if you have one. It is possible to use this pipeline to specify your license key as well, but this is designed for a demo environment, so it gives you a trial version. You can use A2 and you can use these packages. The terms and conditions of Chef licenses means that if you're doing this for experimental purposes, you can go ahead and use this stuff. Where the license provisions kick in is, again, beyond the 60 days for Automate, or if you're using this for production servers. At that point, you'll definitely want to have a conversation with your Chef sales rep if you find value from this, which you hopefully will, and then that will actually then let you get on with this and continue using this in production if you so wish. So that concludes the presentation portion. What I'd like to do now is start diving into some of the questions that we have to dig into this. So our first question is that we are currently using Chef 12 and Berkshelf to manage our servers. How should we migrate to the Effortless patterns? So the ideal case answer there is predicated on you kind of having the enterprise automation stack, which includes Habitat for applications, because effectively part of migrating to the full sort of EAS suite is that a lot of the complex logic you have in Chef actually goes away because you're moving a lot of your application stuff into Habitat. And really what Chef is doing is managing the compliance piece and potentially some configuration like Active Directory, NTP, etc. So really what you would look at doing there is potentially doing some Habitat application migrations to slim down your cookbooks, and then looking at doing an effortless config application for Chef Infra to effectively spin up your Habitat application that will also let you upgrade to Chef 15 at the time. If you are not using Habitat for applications, so if you're using what we would call the Effortless Infrastructure product, so Chef, InSpec, A2, and Habitat for Chef Infra and InSpec, what you'll find is you can still do that in policy files. You can pull all your cookbooks into policy files and migrate to this workflow and migrate to Chef 15. But you will find with doing policy files in this workflow, it will mean, for example, if you have nested policy files where you define a base policy file and then some domain-specific ones, it can cause quite a lot of application rebuilds. So what I would recommend is if you're in a situation where you're going to try and use this without using the full enterprise automation suite, without using Habitat for apps, I would recommend having that conversation with your customer success team at Chef and help us figure out a migration journey for you that's going to minimize pain there. Definitely the smoothest and what I believe is the application workflow that will drive the most value is if you are using Habitat for applications for the application piece. So the next question is whether or not the slides will be made available after the presentation. If you look in the resource list widget, I believe you'll find the slides. I also believe that the recording for this webinar will be up within the next day or two, so you'll be able to access that fairly shortly, I think. So there's a question about someone who used Chef a few years back. What version of Chef is now out? We're basically on Chef version 15 right now. There's about one major release a year of Chef, and correspondingly N-2 is deprecated, but we're currently on Chef 15. Is there a Kubernetes cookbook? I do believe you will find a Kubernetes cookbook on the Chef supermarket. In this workflow, the way we actually think about that is more using Habitat. So Habitat gives you the ability to export packages as Docker containers rather than Habitat artifacts as well. So what you can actually do is use Habitat to drive your Docker image workflow and then leverage Kubernetes orchestration and so on to run those containers. Someone who had a hard stop at 12:25. Again, when are the slides going to be posted? They'll be sent out tomorrow, and they're also available in the resource list widget. Let's see, what do we have here? So someone currently uses Chef Infra with a Chef server and often does ad hoc queries to the Chef server to find info about their nodes, etc. You can basically, like all of the data that you're querying with the Chef search index is in, like all of that OHI information is stored in Automate, and you can still get it the same way and search against it. The only thing I would say to look at is when you're doing things like service discovery and so on. So typically, maybe you're using those search queries to, for example, get a list of all nodes running a particular application if you're using it for service discovery. A lot of the native features that Habitat gives you will actually do that a lot better. So Habitat gives you a much better way of discovering, for example, you're an application server and you need a database server. Habitat gives you a way of exposing that information. Someone is asking, someone's asking, what if the dependencies are gone a few years later? So the way the Habitat depot works is that basically dependencies never go away. The Habitat depot will actually not let you remove a package that something else in the Habitat ecosystem depends on for that exact reason, because we don't want it to break down the line. Similarly, if you have Habitat depot on-prem and you actually are storing your own packages internally, depot will only let you remove packages if nothing else in depot depends on those packages. So it's actually extremely difficult for the dependency to go away. So this is another question about the Chef search functionality that we've kind of touched on. You can still search against the OHI data stored in Automate. Another customer asks, how well does Automate scale? Automate scales extremely well, but actually Automate scales especially well in this particular workload because it's much less heavily impacted. A lot of if we include Automate as including the Chef server piece in a more traditional ecosystem. We're actually taking away the Chef server piece. That's a whole chunk of infrastructure you don't need now because all of the cookbooks go in the Habitat application. So all we're actually using Automate for is sending the status data at the end of the Chef run. We're sending it the Chef client data and the InSpec data, and we're using Automate as the visibility layer. So all of the stuff about cookbook storage and dependency resolution, all the things that really hammer that server actually go away in this model because we're doing the dependency resolution at build time. The Habitat depot becomes the artifact store, and Automate becomes the visibility layer. Next question is, can you explain more about how I can use? Okay, so this is what you can use depending on your license. So this is someone whose license covers Chef Effortless Infrastructure. That does cover using Habitat to manage Chef Client and InSpec. It does not cover using Habitat to manage any other applications. So you can still use these patterns with Effortless Infrastructure, but to use Habitat to manage all of your other applications, so to do that full kind of migration of application cookbooks into Habitat, you do need the enterprise automation stack piece. So someone then asks, we currently use Terraform to build our infrastructure and then use Chef to configure the blank slate VM. Is your proposal that we take an image, use Chef to install stuff on it, and then use Terraform to deploy the VM image? So essentially, kind of yes. What we're doing, I mean, you could basically do this the way you're talking about there. So you start with a completely blank VM. What you could then do is you could install the Effortless config and Effortless audit applications on at provision time, and not do it during the build process. My feeling personally, though, and this comes from experience with typical enterprise use cases, doing it during the build process helps satisfy security and compliance teams that the image you're deploying is already compliant, so that the thing you're starting from is a known good state. You absolutely can do this where you're just doing all the compliance and verification piece at build time, at provisioning time, sorry. But I think in enterprise use cases, typically it actually drives more value to do it during the build process and then have it effectively continually do that during provisioning process to maintain, ongoing compliance. How did you boot Chef server on the Effortless node? Was it something built into the Packer image? Excuse me one sec, let me just take a sip. So if you look in the Packer config, in the Azure Effortless demo repo, what you'll actually see is in the Packer script, we're installing 2 Habitat applications on our Packer image. We're effectively bootstrapping the Habitat supervisor, and then we're running a hab package install command to install our config baseline and audit baseline packages, and then we're executing those packages to do the piece. It is actually much easier than the typical Chef client bootstrap because we're not dealing with the Omnibus installer. We're just installing one Habitat package. So the last question we have right now is, how do you sign images in Chef? I'm not 100% sure. If that question is specifically to do with signing images in Azure, for example, what we're basically doing is we're leveraging all of the native Azure APIs. In this case, I'm producing a managed image. It's not signed because this is a demo environment, but we're not doing anything magical. We're using all of the standard Azure APIs here. So if you wanted to sign an image using, I'm not actually familiar with that mechanism in Azure, but if you wanted to sign an image in Azure, effectively, you can do that exactly the same way. You could add that into the Packer stage that's registering that image, for example. There's no secret sauce. There's no magic here. We're using standard tools, talking to Azure the standard way. If the Packer provisioner for Azure supports image signing, you would absolutely just drop that into your Packer script. So right now, that is all of the questions we have. You have a couple of seconds if you have any last-minute questions to get in, anything you want to touch on again.
Awesome. Thanks so much, Jon. And thank you, everybody, for all the questions. There were a ton. So thanks for submitting those. And hopefully we got your questions answered here. It looks like we're right at the top of the hour. So I am going to close it out. Everybody can get on with the rest of their day. Thanks again, Jon. And for everybody, if you didn't find the presentation in the resource list widget, we will be sending it out tomorrow, as well as the recording. So look for that in your inbox tomorrow. Of course, we hope you found lots of value in the info that was presented today. So if you like what you saw, we definitely encourage you to share this presentation with your teammates and professional networks. Like I said, on-demand version should be available tomorrow, so do look for that. And a quick heads up that we do have 2 more webinars coming up in October. They're both focused on building consistent, compliant, and secure infrastructure with our security theme happening in October. So the first is empowering DevSecOps on Google Cloud. That's on October 16th. And the second is continuous compliance in a DevSecOps world, and that's on October 30th. So you can find more information about those webinars and register on Chef Webinars or Chef Events page. Definitely be sure to register for one of those if those sound interesting to you. And that will do it. So thank you again, everybody. Thanks again, Jon, and have a wonderful rest of your day.
No worries. Thank you, everyone.